So yesterday we talked about how to find the vertical shift in the midline, and we talked about how to find the phase shifts, but we didn't talk about graphing any of it, right? So today we're just going to graph vertical shifts and phase shifts. None of it's going to be put together at all, right? Some problems will just be vertical shifts, some will just be phase shifts, and then tomorrow we'll put it all together into one equation, all right? But I'm just going to finish off the graphing that we didn't do yesterday. So yesterday we said on this example that the amplitude was 2, right? And the period was 2 pi. Right. And we said the vertical shift was 5 units down. And so the equation of the midline was y equals -5. We said all of that yesterday, right? So if we're going to graph this, we need to graph the midline first. All right, that's where our new x-axis is going to be, sort of. So 1, 2, 3, 4, 5. That's our midline. It's a dashed line, so yes. If the amplitude is 2, what's my maximum and minimum values going to be? What are they going to be?
2 and -2.
No, because we vertical shifted. -3 and -7. Right? -5 plus 2, -5 minus 2. Does that make sense? Yeah? Okay. The period is 2 pi. So what am I going to count by for the x-axis for the scale? How are we going to figure that out? Right, 1/2 pi. You're going to do 2 pi divided by 4, which is pi over 2. So pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2. Right, this is a cosine function, right? So if I was graphing cosine without doing the vertical shift, where would I start this from? The top, right? The maximum value, right? So I'm still going to do the same thing. I'm still starting at the maximum value. My maximum value just happens to not be 2. It's -3. Okay, so I'm going to start right here. Then after that, you'll go to the x-intercept, right? We don't have any x-intercepts. We have a new midline that's acting as our x-axis. So we're going to go to our x-axis, our fake x-axis. And then we're going to go to our minimum value, which is -7. And then back to our fake x-axis, and then back to the maximum. So it's the same thing we've been graphing. We just shifted it downwards. Questions about that? So it's the exact same thing, right? I still took the period and divided by 4, figured out the scale. All I had to do was shift it downwards. Questions about that one? All right. Then let's look at the phase shifts. So for this one yesterday, we figured out the amplitude was just 1. The period was 2 pi, right? There's no vertical shift. But we do have a phase shift. I figured out the phase shift by doing C over K. And we decided yesterday that that was -pi over 1. So we said -pi, right? So 1 to -1. The period is 2 pi. Then we're counting by pi over 2. So that's still going to happen. This is a sine curve. You can do this 2 ways. You can graph the original without the phase shift first and then shift it all over, or you can shift it from the beginning. I'm just going to shift it from the beginning. All right, but think about this with me. You don't have to graph this part. But sine normally does this, correct? So this is what the sine curve would look like, right? Well, we're shifting it pi to the left, okay? we still use the same scale as we used on the positive side of the x-axis, but since we're moving it to the left, we need to have some values on the negative side of the x-axis. You still count by the same thing, though. So I'm going to have negative pi over 2, negative pi, right? Because the x-axis can't just you can't just change the scale in the middle because you feel like it. If I'm shifting the curve over negative pi, that means all of those points are getting moved over two segments, right, on our scale. Does that make sense? So let me erase all these real fast. So instead of starting at 0, 0, we're going to start at negative pi. Then sign increases to the maximum value and decreases back to the midline, then decreases to the minimum value, and then back to the x-axis. It makes the same exact graph we've had before, we just shifted it. Does that make sense? If you need to, you can always put the points in that were there originally, and then you can shift them all over. That's what we just did. Okay? Questions on that one? On the second one. Amplitude just 1 again. The period was what, pi? 2 pi divided by 2. And then there wasn't a vertical shift, and the phase shift was positive pi over 2 divided by 2, which makes it pi over 4. Right? Correct me if my math is wrong. Okay, so if we're going to graph this, again, 1 to negative 1. If our period is pi, then what are we counting by? Pi over 4, right? You take pi divided by 4. So pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, right? This is a cosine function. So cosine normally starts at the maximum value at the y-axis, right? But we are shifting this over positive pi over 4. Right? So that's one unit or one segment of our scale. So instead of starting right here, we're shifting that to start right here. Does that make sense? Yes? We're starting at positive pi over 4 instead of at 0. Yeah? Cosine then decreases. We have to show one full period, so I haven't gotten to the point where it's going to repeat yet. So I have to add in one more segment on my scale, so that would be 5 pi over 4. Questions about that? Most of the time, like the ones on the quizzes and everything, most of the time, the phase shift works out to be something that is already part of your scale anyway, so it's not that big of a deal. Sometimes it doesn't. So what if this had been pi over 8 instead? Pi over 8, that's the increments in between here. All right? So a lot of the times they might end up being half of a segment. So then you would shift everything over a half of a segment. But that means you wouldn't hit the points you normally had on your scale. You would hit in between. All right, and there's some on the homework tomorrow that will let you practice that. Okay? I think the ones from Learning Chart 12 aren't that bad. Mm-hmm. Yes, we're going to do all that in Learning Target 13. So Learning Target 13 just puts it all together. We'll do it tomorrow. But it's not that bad. Any questions on stuff today?